Hi everybody, I'm Kirsten from Immerse Science Classes, and we're going to talk about compounds today. Yay, super exciting. I am teaching through Apologia's chemistry curriculum, exploring creation through chemistry, through the year of 2021 through 2022. And if you are part of my class, welcome. There will be 2 videos this week. And I'll be continuing to post videos of things we've talked about in class. So if you missed class, which I know a number of you have, you can go back and watch those from Module 1. But this week, our 2 videos are going to be from Module 2, and we're going to talk about elements and compounds. I will do the elements one later, but first we're going to talk about compounds. And this is in your book. I'm on page 54, so you can follow along with me in your book while we talk about this. If you are not in my class and you are new to my channel, welcome. Subscribe to my channel so that you can go through this curriculum with us through this school year. It's going to be fun, I promise. Okay, so elements. An element is a substance that is pure and is not composed of different parts. It cannot be broken down into smaller components. That's the definition of an element. And scientists have arranged elements into the periodic table. There are currently 118 elements in the periodic table, and these elements make up all of life, and all the substances that are around us and on our planet are all made of these 118 elements. Not all of those exist naturally. Some of them have been made in the lab. But for the most part, these are the elements that make up our life. And when these elements combine into molecules, it's called a compound. A compound is a substance that's composed of elements, and it can be broken down. You can do it chemically, you can do it by heat, but it can be broken down into further components, which are elements. But a compound is a combination of elements. Compounds are not just 2 different kinds of elements smushed together, and it doesn't matter how much of one element that you need. Compounds use a very specific ratio of the elements that they are made of. A common analogy is a recipe. So this is one of my most used recipes from my mother-in-law. But a compound is just like a recipe in that the components of the recipe have to be added in certain ratios, or the recipe won't work. The recipe will not come out right. So like, for example, 1 pound ground beef, 1 teaspoon of onion powder. If you want to double that recipe to feed more people, you have to double all of the components. You can't add more of one and less of the other. You have to completely double everything or triple everything. Compounds are the same way. And that is called the law of definite proportions. All that means is that compounds have to have elements in definite proportions. There has to be a definite ratio between the elements that make up a certain compound. That's all that means. We're going to use an example really quick of salt, table salt. Table salt is made up of 2 elements, sodium and chloride. So sodium is over here, Na, and chlorine is over here, Cl, designated Cl. So sodium is NaCl. Table salt is NaCl, made up of sodium and chloride. If you tried to make table salt, you would need exactly 10 grams of chlorine and 6.5 grams of sodium. (10 grams of chlorine to 6.5 grams of sodium. This is a ratio, 10 to 6.5. And anytime you try to make more table salt or less table salt, you have to use this same ratio. If you wanted to multiply it by a factor of 10, you could do 100 grams of chlorine to 60.5 grams of sodium. Do you see what I say? So it's a certain ratio that always has to be the same. I'm not going to make you do these calculations, but I want you to understand why this is important to know. First of all, the law of definite proportions gave scientists a clue when all these things were being discovered. It gave scientists a clue as to how molecules are formed. It helped them to know that molecules are formed by certain numbers of elements grouped together, and they're actually connected. We'll talk more about molecules later, but it was very important to understand the law of definite proportions, and that is what led to the discovery of molecules and how elements work together. The second important thing about this law is that it enables scientists and manufacturers who are designing and creating compounds to know exactly how much of the individual elements they need to create a certain compound. And your book gives an example on page 56. Here's the question. A chemist reacts 15 grams of calcium with 15 grams of oxygen. So let's do that really quick. So 15 grams of calcium, I'm just going to designate it Ca, and 15 grams of oxygen. A chemist reacts calcium and oxygen, and when you react calcium and oxygen, it actually creates a compound called lime. There's a lot of useful things that lime is used for, but it's a common compound. So a chemist reacts these two elements together, and what happens is this reaction makes 21 grams of lime with an unknown amount of oxygen left. So there was some leftover oxygen. All of the calcium was used up, but there was some leftover oxygen, and only 21 grams of lime was produced. Well, because of conservation of mass, we know that if you put in 15 grams of calcium, 15 grams of oxygen, and it's all used up, you should have 30 grams of lime. But you only have 21 grams of lime. So how can you figure out from this question, first of all, how much oxygen was left over, and second of all, the ratio between the amount of calcium needed and the amount of oxygen needed? Well, you would take how much you should have gotten 30 grams, minus how much you actually got, will give you 9 grams of oxygen left over. 9 grams of oxygen is left over. So chemists can use this to know basically that if you want to make lime, you have to use exactly 15 grams of calcium to every 6 grams of oxygen. We know that because of how much was left over. Only 6 grams was used. So this is the ratio that you must always use if you're trying to create lime. And your book goes into talking about how you can figure out if you want 55 grams of lime in the end, how much of each substance do you need? And that you can figure that out by using the ratios. I'm not going to make you do those calculations. I think it's good for you to understand why it's important to know that there is a ratio and that chemists need to use the ratio because it's important in manufacturing and in chemistry labs. But I'm not going to make you do those calculations. I just want you to understand the importance. So that is the end of my discussion on compounds. Please watch for my next video on elements, which will be uploaded in the next couple days. Maybe tonight. We'll see. All right. Have a great couple days. We'll see you later. Bye.